Alright, good evening, my 7th grade math students. Um, so I told you we were going to watch two videos, one today and one tomorrow, and I decided against it. Ended up staying up way too later than I expected to be yesterday. We're going to try to run through two videos together in lessons 16 and 17, so be prepared. If you have not finished your CFA from yesterday, you better get that done today. Okay? Because if I end up taking a look at those tests and they are not completed, anybody that does not have a completed grade, when I look at them on Thursday, it's going to get a 0 in the grade book. Fair warning now, this is your last chance. You need to get the CFA done today. All right. So lesson 16 is applying the properties of operations to multiply and divide rational numbers. So remember, we're talking about properties of operations. So we're talking about things like the commutative property, okay, the commutative and the associative property. Okay, these tend to be the big ones. However, you could also have the distributive property if it is necessary, and you could also have the identity property if it is necessary. So these are your four major operations that we're talking about, okay, properties. All right, but normally commutative and associative are the big two, okay? All right, so let's look at classwork example 1. Using the commutative and associative properties to efficiently multiply rational numbers. See? Commutative, associative properties. Told you. Big two. All right, so we need to evaluate the expression below. A negative 6 times 2 times a negative 2 times a negative 5 times a negative 3. Well, the first thing I'm going to do, and the first thing you should do, is I'm going to go ahead and count, okay, the number of negatives, okay? 1, 2, 3, 4. There are 4 negatives, which means my answer should be positive. Okay, if you remember that, your answer should be positive because 4 negatives is even. Even number of negatives gives me a positive answer. Okay, now it says just to evaluate the expression below, okay, let's see. You can come up with multiple ways of doing this. One way, you could just go straight across. Negative 6 times 2 gives you a negative 12 times a negative 2 times a negative 5 times a negative 3. Negative 2 times a negative 12 is going to be a positive 24 times a negative 5 times a negative 3. 24 times a negative 5 is going to be a negative 120 times a negative 3. Negative 120 times a negative 3 gives me a positive 360. See, that's one way of doing it. The other way is maybe it'd be better if I group certain things together. Okay? So, like, I'm sitting here thinking to myself, well, why don't I take the negative 6 and the negative 5 together? Okay, could do that. Or would it be better if I took the 2, the negative 2, and the negative 5 and put them together? So let's see that. So let's do that. So we're going to group the 2 times the negative 2 times the negative 5, and we're going to bring it together in a group. And then we're going to multiply that by a negative 6 times a negative 3. Now, what property did I just use? Okay, I used the commutative property to move these numbers together, and then I used the associative property to regroup them. So that's what they're talking about. What properties can you use to make these problems easier? 2 times a negative 5, or let's do a negative 2 times a negative 5, is a positive 10. 10 times 2 is 20, times negative 6 times a negative 3, that's a positive 18. 20 times 18, well, I knew 2 times 18 is 36. Add the 0 at the end, I still get 360 at the end. Okay? So that's what they're trying to get you to understand is in this kind of a situation, we can move the numbers around because it's all multiplication. And then we can regroup to try to make it easier for us to multiply and to solve. All right? So what types of strategies are used to evaluate the expressions? Well, the first thing we did was we counted our negatives. We counted the negatives. All right. In the first problem, we just didn't do anything. We just multiplied straight across. But in the second set, we used the commutative property and the associative property Okay, we use those to actually sit there and try to simplify our multiplication. So can you identify the benefits of choosing one strategy versus another? Okay. Well, if in example number 1, by multiplying straight across, you can ensure that you don't miss a number when multiplying. That's one thing that I could definitely say would be very important. But in the second one, we can make the factors simpler when multiplying. So in the first arrangement, we can sit there and guarantee that we don't miss a number when we're multiplying. But in the second one, we can sit there and group our factors together to make it easier to get better products. Something that becomes a little easier to do, okay? Now look at there. Look at part D. What is the sign of the product and how is the sign determined? We know that's positive because we counted the negatives. Look at there. It's positive because we counted the negatives. We knew that one. Boom, chicka, boom, 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 chicka, boom, 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 chicka, 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 boom, boom, boom. Yeah. All right, let's move on. Okay. All right, so for exercise 1, it says find an efficient strategy to evaluate the expression and complete the necessary work. Okay. Find the efficient strategy. All right, so I'm looking at this. All right, so I got to figure out the best way for me to do this. All right, well, the first thing I'm going to do is I'm going to count my negatives. 1, 2, 3. All right, so my negatives are 3, which means my answer is going to be negative. Okay, I know that because an odd number of negatives gives me a negative answer. All right, now let's use the commutative property first. So we're going to use the commutative property first. And you're asking me, Mr. Hale, what are we going to be moving things around to get? Well, I think it would be better if we had the -1, the -2, the +2, and the -3 first. So it'd be -1 times a -2 times a -3 times +2 times 10. Okay? Now, I think we should use the associative property. Associative property. We're having issues about spelling today. And let's group the -1 times the -2 times, and then we'll group the -3 times 2 together, and then times 10. Okay? Now we just sit there and solve. -1 times the -2 would be 2 times -3 times the -2 is going to be a -6 times 10. Okay? Well, we're going to use the associative property again here. And I know you're asking, why are you writing all this down, Mr. Hale? Because you're going to be doing the same thing at some point. We're going to group the 2 and the -6 together because we want to make sure that's what gets multiplied. 2 times a -6 is a -12 times 10. Okay, -12 times 10 is a -120. Now you're asking, Mr. Hale, how did you know to move all these? Well, I know that it's easier for me to multiply a number by 10 because whatever I multiply by 10 is just going to be itself with a 0 at the end of it. So it was better for me to move the 4 factors away from 10 and push 10 to the end, so that would be the last thing I multiplied. I wanted to make sure that 10 was the last thing we multiplied because it was better for that to be the last thing we multiplied. All right. Now, I wrote everything down on the side because I wanted to make sure that if somebody else was reading the problem, why did I do what I did? What property did I use? Why was that the best course of action? Okay? Commutative property allowed me to move everything in the problem. The associative property allowed me to group things together. The associative property again allowed me to group to multiply. Makes it easier for me to work with. Okay? I have a funny feeling I've already done this lesson with you, but I think this is good that we're doing it again. All right, so find an efficient strategy to evaluate the expression and complete the necessary work. Okay, so 4 times 1/3 times a -8 times 9 times a -1/2. Okay, so we've got to move things around here. Okay, well, remember what we said. The first thing we're always going to do is we're going to count our negatives. So I got 1 negative and 2 negatives. Okay, so so the number of negatives is 2, which means my answer is going to be positive. Okay, so my answer is positive. So that I can tell you that I already know. Now, I need to use the commutative property, okay, because I want to move some stuff around, okay? Now, here's the thing. What do I want to move to get things closer together? I'm thinking to myself, what number would be best for me to multiply by the 1/3? What number would be best for me to multiply by the 1/2? Okay? Now, I know that 3 is a factor of 9. So I think it'd be best if I move the 1/3 times 9 together. Okay? Times, now I got this negative and negative. So I think the negatives here would be best to go ahead and put together. So -8 times a -1/2 times 4. Okay? Now the associative property, all right, will allow me to group what I want to multiply. 1/3 times 9 times a -8 times a -1/2 times 4. Okay? Now I can sit there and solve. 1/3 times 9. Okay, so what is 1/3 of a 9? So if I take my 3 little blocks here and I group them in 3s, what is 1 out of 3? Well, 1 out of 3 is 3. Okay, so 1/3 times 9 is 3 times, negative times a negative is a positive, so what's half of 8? 4 times 4. Okay, so I'm going to use the associative property again. And I'm going to group 3 and 4 together. Gives me 12 times 4. 12 times 4 is 48. Okay. Exercise 3 is asking us what terms did you combine first and why. Okay. Well, the terms I combined first were the 1/3 and 9 because I knew that 3 was a factor of 9. So I could guarantee that I would get a whole number answer when I multiplied it by 1/3. And I knew 8 was even, and that means it would come out to be a whole number if I multiplied it by a half. So I made sure that an even number was with my fraction. And I decided to go ahead and put it with a -8. That way I can guarantee that it stays positive. Okay? So that's the reason why I combined those terms first, and the reasoning behind why I chose those terms first. Okay? All right. Let's keep on going. Okay. Yeah, we have done this one before. I'm sorry, guys. It looks like you're just going to get a nice little benefit here and get a review on this. Okay, so do you see an easy way to determine the sign of the product? We know this. We're going to count. Okay, we're going to count the negatives. All right, if the number of negatives, is even, you get a positive number. If they are odd, you're going to get a negative number. All right. How much I got left? Okay, we're going to make these last couple problems, and then I'm going to give you some work to do tomorrow for class. I'm loving the fact that I'm redoing this lesson. Oh, I guess I did this one in class on the board or something like that, and that's the reason why I didn't have it written in here. Oh well. All right. So, rewrite the mixed number as a sum, then multiply using the distributive property. Okay. Now, I need you to understand that when you get a mixed number like A, B over C, it's the same as writing it as A plus B over C. So, like 2 and 1/3 is the same as saying 2 plus 1/3. Okay? That's important to understand because that is what it's asking for us when it says rewrite the mixed number as a sum. Okay? So what they're asking us to do is we're going to take this -6 times 5 1/3 and say -6 times 5 plus 1/3. Then we're going to use the distributive property. In the distributive property, if you remember, when we have A times B plus C, and I'm using the letters because I prefer using letters, okay, you take the A and you multiply it by each term on the inside of the parentheses. So you get A times B plus A times C. All right, so I want you to imagine that. This is A, this is B plus C. So A times B, negative 6 times 5, plus a negative 6 times 1/3. A times B plus A times C. So they match up. Just like there's written over here, it's the same thing over here. Okay? Negative 6 times 5 is a negative 30, plus 1/3 of a negative 6. So we're going to go ahead and write down our 6 little circles here. I'm going to divide them into 3 groups because that's what my fraction on the denominator tells me to do. Divide them into 3 groups. So what's one group out of 3? It's 2. So 1/3 of a negative 6 is going to be a negative 2. So a negative 30 plus a negative 2. Remember, both of them are negatives, so that means my answer is just going to be negative. So what's 30 plus 2? Negative 32. So that's my answer. Okay? All right. Let's look at part 5 here. So again, we're going to rewrite this as 9 times a negative 3 plus 1/2. Oh, Mr. Hale made a mistake. You want to know how Mr. Hale made a mistake? That negative has to apply both to the 3 and the 1/2. So it's a negative 1/2. Okay? So we're going to take the 9 and multiply it by the negative 3, and the 9 times the negative 1/2. Okay, so 9 times a negative 3 plus 9 times a negative 1/2. 9 times a negative 3 is a negative 27, plus 9 times a negative 1/2 is a negative 4 and 1/2. Okay, because half of 9 would be 4.5, which is the same as 4 and 1/2, and since they're negatives, it's negatives. Okay, so a negative 27 plus a negative 4 and 1/2. 27 plus 4 is 31, and the 1/2 comes down. Both numbers are negative, so my answer is negative. So negative 31 and a half. Okay. All right, so for those that have completed their diagnostic, in class tomorrow, I want numbers 1, 2, and 3 completed. Okay? 1, 2, and 3. All right, let's move on. We are going to move to lesson 17. All right, so lesson 17. Comparing tape diagram solutions to algebraic solutions. Okay? All right, so the classwork. Opening exercise. For his birthday, Zach and 3 of his friends went to a movie. They each got a ticket for $8 and the same snack for the concession stand. If Zach's mom paid $48 for the group's tickets and snacks, how much did each snack cost? Okay? The equation 4 times s plus 8 equals 38 represents the situation when s represents the cost in dollars of one snack. Okay. This is what you call a two-step equation. Only thing is we don't want to solve this as a two-step equation. So we got some work we got to do. All right. Now, here's the interesting thing. Okay. So I can do something that's called a tape diagram. Okay. It was Zach and his 3 friends. That means 4 total people went to this thing. Okay. Now, the whole thing, this is what you call a tape diagram. This whole thing right here is $48. But each person, okay, okay, got a snack and spent $8 on the ticket. And you're like, Mr. Hale, where'd you get this from? 4 people got a snack plus $8. 4 people got a snack plus $8. Okay? So now here's my question to you. If each of these blocks equals $48, how much does one block cost? Okay? So how much does one block cost? So I got 4 blocks, $48. 4 blocks, $48. 4 blocks, $48. 4 blocks equals $48. Could I have a division problem on my hand? Could it be $48 divided by 4? Okay, 48 divided by 4 is 12. So that means each one of these blocks, ooh, that's a nasty little thing there. Each one of these blocks is valued at $12. So instead, we now have the snack plus $8 equals $12. So my question is, how much did the snack cost? How much was the snack? Okay, so how much was the snack? Well, what number plus 8 gives me 12? Ah, $4. So each snack was $4. Now you're like, Mr. Hale, what in God's green earth did you just do? Well, I did what we call a tape diagram. Okay? The more you practice this, the better it becomes, the easier it becomes. Now, I know this looks difficult. I know it looks like a pain, okay? That's the reason why we're going to do the exploratory challenge in class together, and I'm not going to make you do it right now. All right? Let's see. Let's keep on going. Okay. All right. A lot of lesson 17 is going to have to be done in class, but let's go ahead and look at this one here. The cost of a babysitting service on a cruise is $10 for the first hour and $12 additional for each hour. Okay? If the cost of babysitting baby Aaron was $58, how many hours was Aaron at the sitter? Okay. So we have a base pay. A base pay of $10 per hour. $10. That's the first hour. $10 for first hour. Okay. Then we have an hourly pay. Okay. $12 for each hour. And then we have our total cost. Okay. Total cost being $58. Okay. Now, we need to write an equation first before we can do anything with the tape diagram. So, I know that my first hour cost $10. Okay. Now, what if I spent 3 hours? Okay. My first hour is $10, but then each additional hour is an extra $12. So that means it's $10 plus another $12 for 2 hours. So that'd be $24. Ah, that's interesting. So this is what is our dependent variable. Okay. This is what we call a dependent variable because this is dependent on the number of hours. Okay. So this is where you get your variable. $12x plus 10 equals $58. So what I don't know is how many hours. Okay. How many hours did this person keep this baby? Okay. So if I made my tape diagram, the total is $58. Okay. I know the entirety of the box is 12x plus 10. Okay. So now I need to figure out how many hours. How many hours were there? Okay. So that's what I got to find out, is I got to figure out how many hours did this babysitter actually exist. Okay. So now we got ourselves an interesting scenario. We can do this in multiple ways. There's a lot of information missing. See, I can already sit here and see the answer because I can already, I mean, my head's already clicking. I know what the answer is. And it's sitting here like, okay, Mr. Hale, what's the answer? Well, the answer is x equals 4. Okay, it's 4 hours. And you're like, no, it's not 4 hours. I said, yeah, it is 4 hours. You don't believe me? It's 4 hours. No, it can't be 4 hours. I'm telling you, it's 4 hours. Okay, well, prove it. Okay, well, fine, I'll prove it to you. All right, so in a two-step equation, okay, the idea is to get the variable by itself. Okay, so we do the opposite of the addition, which is subtraction. So we subtract 10 from both sides. You get 12x. 10 minus 10 is 0. equals 48. Okay, 12x equals 48. Now this is a multiplication problem. Multiplication, the opposite of multiplication would be division. So we divide both sides by 12. 12 divided by 12 is 1, leaves us x equals 48 divided by 12 is 4. X equals 4. It would be 4 hours. Okay? I know, you're like, wait a minute, how in the world are you getting that? It's a long story, okay? We're going to actually work on this one again in class, too, okay? Oh, I'm sorry. I didn't show you all the work. We're going to work on this one in class, too, because I think it might be beneficial for us to do a little bit of practice on these in class. Not all tape diagrams are easy. Not all of them are self-explanatory, okay? They tend to get a little bit of a pain in the buttish. Ooh, this one we're definitely saving for another video. I don't want to rush that, okay? So here's the thing. I want you to give 2 problems a shot, okay? I want you to try number 1 and number 2 for me, okay? Give it a shot. See if you can make a tape diagram, okay? Or see if you can find out what the answer is, all right? You do that for me. We'll do the rest of it in class, okay? So no rush, no hurry, all right? Like I said, with that, that's going to be the end of the video for us tonight. So make sure that you finish your CFA. Make sure you've watched this video, and make sure you're ready for me in class on Thursday. We've got a lot to do and not a very lot of time doing it, okay? I want you guys to have yourself a good day. Make sure you get all this stuff done for me, okay? You guys know that I love you, and I hope you all had a fantastic fall break, and I will see you all as soon as possible. All right. Bye, guys.